Hi, but in this lesson we look at a quadratic word problem where we have to find the maximum. So when we're asked to find the maximum or the maximum selling price or something like this, generally we have to find the vertex of a quadratic function. So in this problem we're told John makes toy portal guns to sell at a science show. Each unit costs $6 to make. He plans to sell the units at $10 each, the same price as last year when he sold 40 units. He figures that for every 50-cent price increase, he will sell 4 fewer units. What selling price will maximize his profit, and what will his profit be? So, in this problem, the trick really is to figure out what we need to let our variable be. This is a classic quadratic word problem where we're asked to maximize either revenue or profit. And in this case, we're asked to maximize profit. So here we have to find the vertex, but first we have to come up with a function, a quadratic function, because we weren't even given a function in this question. So let's introduce a variable. Let's let x represent the number of price increases. So we let x represent the number of price increases, and let's let and p of x the profit. So now we have to figure out a way to relate p of x and x in order to get a quadratic function. So first let's think about what profit actually is in this question. So profit is going to be the quantity. So profit is going to be equal to the quantity sold, I guess, times the profit per unit. Times the profit per unit. Now, the quantity, let's think about what the quantity is in terms of x. Well, the quantity is going to be, last year he sold 40 units. So let's write 40. And for every 50-cent increase in price, he's going to sell 4 fewer units. So what represents the number of increases in price is our variable x. So every time that x increases by 1, he's going to lose 4 units. So our quantity is going to be 40 minus 4x. Then we have our profit per unit. So the profit per unit, let's just say, that's going to be equal to, well, he's going to, last year he sold the units at $10 each. And for every 50 cent, or for every increase in x, he's going to earn an additional 50 cents. So now you have to think about this. Is this profit? Well, I've got $10 plus 50 cents for every price increase, but you have to factor into the price. You have to factor into this that each unit costs him $6 to make. So this actually isn't profit. This is the revenue per unit. So we have to subtract $6 from the $10 that he charges for each unit, and we're going to get $4 plus 0.5x. So our profit, p of x, is going to be equal to the quantity sold, which is 40 minus 4x, according to John's estimates. So 40 minus 4x times 4 plus 0.5x. Now, our goal here is to figure out what value of x maximizes the profit, and we also want to figure out what the maximum profit is. So we could expand this and then use partial factoring or use completing the square to figure out what the vertex is. But there's actually an easier method, because this this expression is already written in factored form. I mean, I could common factor, but I can figure out what the zeros of this function are really, really easily. So I'm just going to go ahead and I'm going to let p of x be equal to 0. And that gives me an equation. 0 is equal to 40 minus 4x times 4 plus 0.5x. Now, 40 minus, there's two solutions to this equation. One of the solutions is that 40 minus 4x is equal to 0, which would mean that x is equal to, well, if 40 minus 4x is equal to 0, x is equal to 10. And then my other solution is when 4 plus 0.5x is equal to 0, and 4 plus 0.5x is equal to 0 when x is equal to 8. So I've got two solutions. X is equal to 10, and x is equal to, oh, whoops, sorry, this should be negative 8. Negative 8, because 0.5 times negative 8 plus 4 is 0. So those are my two solutions. Now, these are the x-intercepts of my parabola. Now, the goal here is to figure out what the vertex is. Now, the x value of the vertex is going to be halfway between these two values. So in order to get the x value of the vertex, I add up these two values and then divide them by 2 to get a value that's halfway in between them. I just average the two values. If I do that, I find that the x value of my vertex is 10 plus negative 8 is 2. 2 divided by 2 is just 1. Now to get the y value of my vertex, I'm just going to compute p of 1. P of 1 is just 40 minus 4 times 1 times 4 plus 0.5 times 1. If I compute that, I get 36. So 40 minus 4 is 36. So 36 times 4.5. And if you compute that, you get 162. So 36 times 4.5 is 162. So let's figure out what this information means. Well, so we've got that the vertex is 1, 162. And we know that the second value, the second coordinate, or the second value in this coordinate represents the maximum profit. Now let's think about what x means. X is the number of price increases. So since we have one price increase and our original price was $10 and we have one 50-cent price increase, that means that our price per unit is going to be $10.50. So the question, if you go back up to the question says, what selling price will maximize his profit? So we can write, therefore, let's actually show this algebraically first. So the selling price is going to be equal to it should be $10 plus 1 times 0.5, which is equal to 10.5 or 1050 since we're representing currency here. Lastly, we should say, therefore, the maximum profit is $162 at a selling price of $10.50. So you can see that it's not always, you don't always have to use partial factoring or complete the square to find the vertex. If your expression is already written in factored form, sometimes it's easier just to find the vertex by solving for the zeros of the function. So that concludes this video, and we'll see you in the next lesson.